Hi guys, so today we are going to solve triangles that are not right triangles. Up until this point, we've really dealt with right triangles. We've used Pythagorean theorem, our trig ratios with SOHCAHTOA. All those things worked really well for right triangles. So what we're going to look at today are some different ones. So just a little bit of review here. To solve a triangle means to find all missing sides and angles. The uppercase letters are going to be the angles. The lowercase letters are the sides. And then the same letter angle and side are across from each other. So the same letter is across from the other one. Also remember, the biggest side is across from the biggest angle. And the smallest side is across from the smallest angle. This is a good way to check your answer to make sure it's reasonable. So for a right triangle, we could use trig ratios and Pythagorean theorem. But what we're going to deal with now are triangles that are not right, triangles that we call oblique triangles. So what we can use is something called the law of cosines or the law of sines. And these actually are not going to be too terrible. There is a special case that's a little bit harder that we'll look at next class. But overall, this actually is something you probably could have done in geometry. So we're going back to geometry to help us figure out when to use which case. I'm going to use some acronyms that you learned back in geometry. So if you remember when you were trying to prove that triangles were congruent, you use letters like side, 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 and angle, side, angle. I'm going to use those just to look at the cases that we have. Now, you don't have to know these. There's different ways to learn it, but I think it's a little bit faster. So if you look at this first case, we know two sides, and we know the angle that's in between those. So let's say you were back in geometry, you would have called this side, angle, side. So two sides and the angle that's in between. If you just knew three sides, like this next one, that's side, side, side. This next one over here, there's two angles. So this is either side angle, angle, or angle, angle, side, doesn't matter which way. Or you could have angle, side, angle. Either way, you have two angles. Now, the nice thing for today, there's not really going to be a difference between these two. What's really going to be important is recognizing on this example that the angle that you have is in between the two sides. And we'll look more into that here in a second. So the reason I point those out is because what information you have is going to determine if you're going to use the law of sines or the law of cosines. So to start here, once my slide changes, there we go. We're going to start with the law of cosines. It's actually a little bit harder. Law of sines is actually a little bit easier. So there are two cases when we will use the law of sines, and those are the two triangles that we just saw above. If we know side, angle, side, or we know three sides, then we're going to use the law of cosines. Now, if you look, this equation is written three different ways. Now, those letters actually can be anything besides A, B, and C. This is just three different ways of writing the same equation. But what you'll notice in all these equations is that whatever letter is over here is the same as the letter that's here. So if this is B, this is B. If this is C, this is C. Now remember, lowercase letters mean sides, uppercase letters mean angles. So what we have here, those are all sides, and those are sides. So what that means is that whichever side is by itself is the same letter as the angle that we're using. So the side that's squared and by itself is across from the angle in the equation. So all that to say, this is a little bit easier if we see a picture. So for all these questions, what you're going to want to do first is draw a triangle that matches this information. It doesn't need to be All right, so we're going to go ahead and start with this first example. Now, whenever we see these questions, the first thing we want to do is draw a triangle. That helps us to see which information we have, what we're looking for, and which equation we're going to use. So this is triangle ABC. Angle A is 56. Side B is across from angle B. Side C is across from angle C. So we'll notice I have two sides and an angle. For today, that's going to be law of cosines, but there's a special case we'll look at that also has two sides and an angle next class. So that's why it's important for us to realize not only do we just have two sides in any angle, we have two sides and the angle that's in between those two sides, and that's going to be really important for today. This is an example of side, angle, side. The other thing you'll notice, all three letters are different. That's another distinction for this case. So this is a case where we're going to use the law of cosines. Now, when we're using law of cosines and we're solving a triangle, the first thing we want to find is the third side. Okay, that's what we need to find first. We don't have enough information yet to find an angle. So to find this missing side, I need side A. So I'm going to use the equation that has A. So A squared is equal to B squared plus C squared minus 2 times B times C cosine 56. And when we solve for a missing side using the law of cosines, this is actually a really easy problem to solve because my variable is already by itself. All I have to do is plug 10 squared plus 11 squared minus 2 times 11 cosine 56, that entire thing into our calculator. But also make a note on your calculator. We are using the cosine of 57 degrees. So you need to change your mode to degrees. So be careful about that. We're going to be in degrees for this whole part of the unit. So plug all that into your calculator, you're going to get the value of A squared. Now notice, again, that's the value of A squared, not the value of A. So when we plug that in, I get that A squared is 97.98. And again, if you just thought that was your answer, you'd know that wouldn't make sense. Having a side of 98 compared to 9, 11, and 10, it's kind of a large jump. It's actually not even possible. So if it's A squared, I need to square root that answer, and I'll get my real answer of 9.9. Now, what we also need to do, it says to solve the triangle, find all missing sides and angles. Well, now that we know all three sides, we can find one of our missing angles. Now, it doesn't matter which angle you find first. Whether you want to find B or C first is up to you. But we really only need to use the formula to find one of them, because we know all three angles are going to add up to 180. Let's just go ahead and find angle B. So if I'm going to use angle B, if that's what I'm going to look for, I'm going to want to use the formula that has angle B. Now again, these letters can be different, but notice if angle B is the angle that we're using, side B that's by itself on the other side is the side across from it. So when I set this formula up, I'm going to set this up so 10 squared is equal to my new number 9.9 squared plus 11 squared minus 2 times 9.9 times 11 cosine B. Now, this is probably the hardest way to use these formulas that we're going to look at, and this is also probably where the biggest mistake occurs. What a lot of people want to do is just combine all these numbers together and write it in front of cosine B, but we can't do that. The reason we can't do it is because 2 times 9.9 times 11 is all multiplied by cosine B. There are no pluses or minuses in between any of that. That is all one term. One term, like if you have 3 minus 4x, you can't just say, oh, that's negative x. Okay, you can't combine unlike terms together. So what we can do, I can plug in 9.9 squared plus 11 squared into my calculator. And I can plug in 2 times 9.9 times 11 into my calculator and get those numbers. But remember, 217.8 times cosine B is one term. I cannot combine the 219 and the 217 together. It's not going to work. What I can do is I can subtract 219.01 from both sides. If I do that, I'll have a negative 119.01 equals negative 217.8 cosine B. Well, now my goal here is to get cosine B by itself. So we'll divide both sides by negative 217.8, which tells me that cosine of B is equal to, I'm just going to leave it as the fraction because I don't have a calculator on me. I'm just going off my notes. Okay, so that's what the cosine of B is equal to. Now, if you remember back from before Christmas break, if we want to find what angle B is, if I know that the cosine of B, if I'm looking for an angle, I have to use inverse. So at this point, what I would do is cosine inverse of 119.01 divided by 217.8. So plug in cosine inverse of that fraction into your calculator, and that's going to give you that angle, which is 57 degrees. Now, once we know what angle B is, again, I'll just list that over here. So angle B is 57 degrees. Now it's actually going to be pretty easy to figure out what my third angle is because all of these angles add up to 180. So all I have to do is take the other two angles, 180 minus 56 minus 57, which is going to be 67 degrees. And I'm done. I've solved my triangle. All right, so the next situation is another case where we'll use the law of cosines. And this one's probably the easiest to recognize that we'll use law of cosines. So this is triangle X, Y, Z. So side X is 15, side Y is 25, side Z is 30. So we know three sides and we don't know a single angle. If we don't know any angles, we have to use the law of cosines. Now it's up to you which angle you want to solve for first. I will solve for angle X first. So if I want to solve for angle X, side X has to be the side that's by itself. The other two sides are the other two letters. It doesn't matter which order they go in, as long as you use both of them. So again, this doesn't have the same A, B, and C letters. But again, whichever angle I'm solving for here, that's the side that's by itself on this side. So at this point, we're going to solve this one just like we did the last one. We'll go ahead and plug in 15 squared into our calculator. I'll do 30 squared plus 25 squared. And again, remember, you cannot combine the 1525 and the 1500. Okay, the 1500 is attached to cosine X. You cannot combine those numbers together. All right, subtract 1525 from both sides. Then to get cosine X by itself, we can divide by negative 1500. Then at this point, if I want to solve for the angle, remember we use inverse. So cosine inverse of 13 over 15 is going to give us angle X. So angle X is going to be about 30 degrees. All right, so then you can pick, again, it's up to you if you want to solve for angle Y or angle Z next. Whichever one you pick, the other side goes by itself across. So pause the video, try either solving for angle Y or angle Z on your own. I will tell you on the video, I'm going to solve for angle Y on the video. All right, so I'm going to go ahead and solve for angle Y. So if I'm solving for angle Y, the side that's going to be by itself in this equation is 25. So I'll do 25 squared equals 30 squared plus 15 squared minus 2 times 30 times 15. I'm going to run out of space here. Cosine Y. Again, remember, the negative 2 times 30 times 15 is attached to cosine Y. We cannot combine those numbers together. So I'll go ahead and simplify this. So I'll do 25 squared on the left side, which should be 625, but I'm grabbing my calculator to double check. Yep, 625. So then I've got 30 squared plus 15 squared is 1125 minus 2 times 30 times 15. Sorry, let me just do 2 times 30 times 15, which is going to be 900. So that, again, that's 900 cosine Y. Those are attached together. All right, so then what we're going to do is get the negative 900 cosine Y by itself. So I'm going to subtract. So 625 minus 1125 will be a negative 500. We'll divide by that negative 900, so that's just going to be 5 over 9. And in order to find an angle, I need to use inverse. So I'll do cosine inverse of 5 over 9 to find angle Y. So I'll do that on my calculator. Again, make sure your calculator is in degrees. And when I plug that in, I'm going to get 56 degrees. Well, now that we know 2 of those angles, we can go ahead and find the third just by subtracting from 180. So 180 minus 30 minus 56 is going to give us angle Z. And again, if you think about this, it's going to make sense for the problem that we have. The biggest side was the 30. Angle Z is the biggest angle, so biggest side's across from biggest angle. The smallest side was the 15. That's across from the smallest angle. So our answer should be reasonable. All right, so now we're going to move on to the law of sines. So the law of sines is actually easier to use than law of cosines. We're going to use the law of sines as long as we know two angles. So once we know two angles, we can use the law of sines. And all it is a proportion. We're only going to kind of work with two of these at a time, but all of these are equivalent. So you can use these two, you can use these two, you can do the A equals the C one. Doesn't matter which two fractions you pick, just pick two, set up your proportion, and solve. So again, there is one other case besides the two angles, and that's the special case that we're going to look at next class. But let's go ahead and draw this. Here's triangle A, B, C. So angle A is 48, angle B is 22, and side A is 5. So this is technically angle, angle, side, but it doesn't matter where our angles are. As long as we know two angles, we're going to use the law of sines. So to do this, we're just going to set up a proportion. So I'll do the sine of 48 divided by the side across from it, which is 5. That's going to equal the sine of 22 divided by the side across from it, which is B, which I do not know. At this point, all I need to do is cross multiply and divide. So 5 sine 22 is equal to B times the sine of 48. The biggest thing you need to make sure about here, you're doing 5 times the sine of 22. You cannot do the 22 times the 5 and make that the sine of whatever that angle is. All right, the 22 is the only part of the sine argument. So the 5 is multiplied by the entire thing. So at this point, if you want to get this by itself, you would divide both sides by sine 48. And that is what you would plug into your calculator. Again, make sure your calculator is in degrees. And once we plug this in, this is a side, so I'll round to the nearest tenth. So side B is 2.5, which again, it's reasonable because angle B was smaller than angle A, so side B was smaller than side A. All right, we'll use the same thing to solve for side C. But in order to solve for side C, we need to know angle C. So to figure out angle C, 180 minus 48 minus 22, which gives us 110 degrees for angle C. So then we just set up a new proportion. So I'll use this original one just because it wasn't rounded. So sine 48 equals the sine of 110 over C. Cross multiply, again, do not make that 550, it's just the sine of 110, and it's 5 times that. I usually write the 5 out in front just to make sure we're careful, but if you put parentheses there, you could put it after. So this is C times sine 48. Divide by sine 48 to get C by itself. And then you are just going to plug all of that into your calculator. So 5 sine 110 divided by the sine of 48. And I get that side C is 6.3, I'll just write 6.3 over Newton tenths. And that is side C. All right, we'll do one more with the law of sines. So again, we know two angles. As long as we know two angles, we can use the law of sines. It doesn't matter kind of what setup we have as long as there's two angles. So angle P is 40, angle Q is 75, and side R is 4. So again, technically this is angle, side angle. We're still using law of sines, whichever way we have. Okay, if there's two angles, we're using law of sines. So to set up our proportion here, in order to do this proportion, no matter which side we're solving for, I need to know angle R, which I currently don't. So again, to find angle R, all of those angles are going to add up to 180. So 180 minus 40 minus 75 gives you angle R, which is 65. At this point, you can set up a proportion. So sine 65 over 4, and it depends which side you want to find first, P or Q. I'll do P. So sine 40 over P. Cross multiply. So 4 sine 40 equals P times the sine of 65. Divide both sides by the sine of 65. Plug that into your calculator, and you'll get your answer, which is 2.8. Okay, again, smaller side, smaller angle. All right, let's do this last one. This should end up as my biggest side because it's across from the biggest angle. So sine 65 over 4 equals sine 75 over Q. So 4 sine 75 equals Q times sine 65, and divide. So 4 sine 75 divided by the sine of 65 gives us 4.3. Biggest side is across from the biggest angle. All right, so that is it for law of sines and cosines. Again, the hardest thing is probably going to be those law of cosines questions when you're trying to find an angle. And then the only other thing that might be tricky is figuring out which formula to use when. So remember, when you know two angles, we use law of sines. And then we're going to look at a special case that'll use law of sines next class.